resuming where we left off with this problem, we encountered a quadratic. When we encounter a quadratic, we set it equal to 0. And then we try to factor. Now, lucky for us, this is not X method factoring. We're just looking for a product of positive 4 and a sum of negative 5. So X minus 4 and X minus 1 equals 0. So X equals 4 and X equals positive 1. So you set each of those equal to 0 and solve for X. So we got two solutions. Well, maybe we kind of have to plug them back, both back in to see if they actually work. So if I plug in 4 minus 2 is 2 on the left side. And what's the square root of 4 on the right side? 2. So we got 2 equals 2. So that one is all good. And then I plug in 1. 1 minus 2 is negative 1. And then the square root of 1 is positive 1. Folks, does negative 1 equal positive 1? That's a no. So 4 is my only solution. 1 is extraneous. You don't have to label it extraneous. You can just cross it off to show that it does not work. So folks, this is important because on this one, there was no real red flag point in this problem. So that's why I always recommend plugging back into the original equation to see if you get something true. On this next one, any ideas? Can I just square root this whole side and have it get rid of both square roots? Well, technically, I have 2 chunks here. So if I were to square that left side, I would have to FOIL. Do I want to FOIL square roots? Nothing. No, we do not want to do that. So what we're going to do instead is we're going to add this radical over to the other side. So we get square root of 2x minus 5 equals square root of x plus 3. So now we have a square root on the left and a square root on the right, and they are both isolated. So we can just square both sides and obliterate both square roots. So 2x minus 5 equals x plus 3. Solving for x, we subtract x, and we get x. Add 5. And we get 8, and now we got to plug back in to make sure that our answer works. So 8 times 2 is 16. 16 minus 5 is 11. Square root of 11. Ooh, gross. And then plugging in 8 to the other square root. 8 plus 3 is 11. So square root of 11 minus square root of 11, that is indeed AU0. So x equals 8 really is our solution. So be careful with the foiling. And if there is more than one radical, put 1 on each side. Go ahead and take a look at F. On F, we would first subtract 5. No big deal. Do we need to go any further? We've got a red flag because we're saying the square root of something is equal to negative 2. So at this point, you could automatically say no solution. But if you're like, I don't catch red flags, Mrs. Cairo, it's not really my thing, we can go ahead and try to solve this. And when I square both sides, we get x minus 5 equals negative 2 squared is a positive 4, because negative 2 times negative 2 is a positive 4. We add 5, and x equals 9. So 9 minus 5, if I plug it back in, is 4. Square root of 4 is 2. And 2 plus 5 is 7. Yeah, 7 does not equal 3. So this is not a viable solution. So that's why our final answer, when none of the solutions work, is no solution. So, folks, I think we're going to be stopping there for today. What I would like you to do is in your homework packet, you can work on number 41, 42, and 43. Check for extraneous solutions. So top row, all of them. So 41, 42, 43 you can do. 46, 47, and 48. So pretty much any that have the square roots with them. So 41, 42, 43, 46, 47, 48. And then on the back, the bottom row, 53, 54, and 55. If you haven't already, I know we've had some people gone here and there, change number 51 to be to the 3/2 power instead of to the 2/3 power.